Welcome to Electronics Specify Insights, the podcast for electronics engineers. I'm your host, Paige Hookway. In today's episode, we explore the rapidly evolving world of automotive computing and the shift towards software-defined vehicles. As modern cars become increasingly complex, managing everything from safety systems to AI-driven features, the demand for powerful, centralized processing platforms has never been greater. I sit down with Nicola Concer, Head of Product Marketing for Automotive Processors at NXP Semiconductors, to discuss the company's S32N processor family, what it is, why it matters, and how it's helping to reshape the architecture of tomorrow's vehicles. I hope you enjoy this episode. Let's get started. Today, I'm pleased to be joined by Nicola from NXP Semiconductors, who is the Head of Product Marketing for Automotive Processors. So thank you very much for joining us. Would you like to introduce yourself for us?
Yeah, hi everyone. So my name is Nicola Concer. I am the product marketing lead for the automotive processor at NXP. I've been in the company for about 15 years, covering all sorts of automotive space, from networking to inverter, traction inverter technology, and now our latest and greatest automotive processors.
Perfect, thank you. And can you tell us a little bit about NXP as well?
Yeah, absolutely. NXP is a Dutch company, publicly traded, headquartered in Eindhoven. We are innovators in the semiconductor space, covering automotive, industrial, and IoT, the portfolios. We develop system solutions that make the connected world better, safer, and more secure. So we do have around 32,000 employees, 11,000 engineers, and we are covering more than 30 countries. So I would say we are a medium-large company for the European standards.
Perfect. Thank you very much. So I'm looking forward today to talking a bit more about the automotive space and the software-defined vehicle, and specifically the S32N family, which is positioned at the heart of the software-defined vehicle. So what fundamental shift in vehicle architecture is driving the need for this new class of processor?
Yeah, absolutely. So what you see in the market today is it's all about innovation and deploying of the so-called software-defined vehicle. Software-defined vehicle simply means a vehicle that can be updated and upgraded when it's sold to the customer. So it used in the past, when you buy a car, that's the moment the car becomes old, and instead, when you buy an SDV car, that's the youngest version of your car. It gets the oldest version of your car. It gets better and better over time because functions get updated and installed as you go. And to enable software to be deployed, you need to have a platform that allows you to install this software, to update it and upgrade it. And therefore, you need an architecture that has less ECUs, but rather a few larger compute engines that allow you to run multiple functions, multiple domains in parallel. And this is really what is driving very much also our own portfolio.
We often hear about centralized compute replacing distributed ECUs. So what are the real-world benefits for OEMs in making that transition?
Well, the benefits are publicly visible. Often you can see many OEMs when they launch a vehicle, they say we reduce the ECUs from 32 to 7. We reduce wiring harness from 10 kilometers to 5 kilometers, right? So they can really, so the benefit on the physical space is obviously less ECU, less metal, less weight, so less cost and more energy efficiency. That's on the mechanical space. But when you look at the software side, it is really enabling you to create this foundation that allows OEM to deploy new capability over time, and that is really very much the requirement, as we said earlier, to meet the SDV capabilities.
Perhaps you can tell us how the S32N family sits within NXP's broader automotive portfolio. You know, what gap is it specifically designed to fill?
Yeah, absolutely. So NXP has a very wide portfolio of microcontroller microprocessors, and in my product line in particular, we cover the higher end version, the higher end space of the compute space. Our current products, the one that are in cars today, they are called S32Z as a zebra and G as a goal, as a gateway. And what is Z? S32Z is a very large microcontroller designed in 16 FinFET technology, meaning that it can go very quick, it can go up to 1 gigahertz in compute power, right? And this allows you to integrate functional safety functions or safety relevant functions into one microcontroller, right? The other side is S32G. This one is absolutely a market leader in the gateway space and the early central computer space. And we actually have two versions. The G2 is interesting because the G2 was launched as a gateway processor. So we have a compute, a real time, an application cores together, but also an Ethernet switch and a communication engine dealing with CAN, LIN, and FlexRay. So this was the G2, and we launched it. It was an immense success for the company. But our customer asked for more consolidation, the ability to add not only gateway, but also adding, for example, body functionalities or gateway plus motion functionality or even gateway plus ADAS functionalities. And that pushed us to deliver a bigger microprocessor that's called now G3, S32 G3. That's the one that we are in production today. So the S32N essentially takes these two foundations and merge them and fuse them together. And that's where you have the S32N5, that is essentially a 5 nanometer super microcontroller, and then the S32N7, that is like a 5 nanometer super S32G with a lot more capabilities. So it is really covering this higher end space of the market that is, as we just discussed, is required to meet the SDV foundation requirements for the future vehicles.
So let's focus on the S32N55 then. What were the key design priorities there?
So their S32N55 was designed with our lead customer, and the goal here was a super integration and consolidation of dozens of real-time ECUs. The goal was to really take these functional safe ASIL B, ASIL D functions taken away from dozens of boxes and put them all together in one place. Right. So the priority is high level of compute, high level of isolation, support for mixed criticality of execution, so QM, ASIL B, ASIL D, but also access to the networking side. So we do support CAN, LIN, and FlexRay, and so on. So it's really the replacement for real-time ECUs today in one supercomputer.
Yeah, I think the big thing here is that it enables multiple vehicle functions to run in isolation on a single chip. So how important is that hardware enforced isolation for safety critical applications?
Absolutely. So we're talking about having different functions, different domains running on the same chip. And that is great, but they have to be separated. They should not step on each other's toes. They have to be independent from execution, for boot, for update, or even for reset. Sometimes, I didn't know, but sometimes when you're driving and there is an issue in the ECU, the ECU gets resetted, right? So you need to reboot the ECU, and this has to be completely executed in a bubble, in isolation compared to the rest. So what we have in this processor is the ability of defining what we call software-defined hardware-enforced partitions. But really, for now, let's call it bubbles. You create these bubbles where you put your functionalities in there, and each bubble is completely independent from each other, not only for execution and safety and boot, but also for my P protection, because we know that some of the ECUs each ECU has its own ecosystem, the tier ones, the suppliers, the teams, the life cycle, right? So we create these bubbles, these isolation partitions, where each team can fully control the SoC on their space and be independent and isolated, also protected from other, let's say, partners that are sitting next door in the same chip. So this is really a unique capability, and this is one of the main reasons several OEMs are choosing our device going forward.
I'm interested with the announcement of the S32N7. What are the biggest advancements compared to the S32N55 generation?
Yeah, absolutely. So the N7, as I said, is taking this to the next level. So we inherit a lot of the N55. In fact, most of the software for N55 is compatible to N7, so we release one software bundle to run both devices. But the N7 takes it to the next level. We add application cores. So the application cores are there to respond to the fact that there is a need for faster update, faster software upgrade and rollout. And that means using a more flexible operating system, more flexible systems like the application cores give you. Then we have a much larger Ethernet switch that allows you to connect to more zones rather than N55. We have a very powerful set of accelerators. And these accelerators are there to do intrusion detection, so high-level Ethernet processing, because we have a bigger Ethernet switch, so we need to process the data that comes in, but also for AI, because now we have our customers are really asking us to deploy more AI functionalities in our chip, to support more AI functionality in the chip. And what we have now is these engines that allow you to run a lot of these functions. And the last but not least, in a higher end version of the N7, we have these PCIe services, or they are, okay, between you and me, let's call it PCIe switch. The engineers will shoot at me. It's not a switch, it's a non-transparent bridge. But the point is, you can have multiple masters in talking. Usually in the PCIe world, you have one master and a number of slaves. And if you want to have multiple masters to talk to each other, you need to have something in between. And S32N7 gives you that something in between. So that means now your autonomous driving system or your infotainment system can talk to each other through the PCIe world, which is extremely efficient. It's 10 times more efficient than Ethernet for software communication. But then you can also attach common storage, for example, or AI accelerators. So it's really the best technology for in deploying high bandwidth communication inside a centralized ECU. So it's really cool technology, and it's really driving a lot of interest on the customer side. So you guys should pay attention to it. It's really cool.
Yeah, definitely. And I mean, you mentioned AI. I mean, how do you see edge AI transforming core vehicle functions beyond infotainment and ADAS?
Yeah, absolutely. I was in a conference last week to discuss about data formatting, and AI was everywhere. AI was everywhere, and it was not, and everyone was saying it's explicitly not for infotainment and ADAS. It's really the AI in the vehicle, and it's coming. It's already there in some cases. What is AI for the vehicle means? So the first step is adding inference. So adding inference on the edge, meaning that the data that you have now in the central computer can be used to create new capabilities or to expand existing capabilities. For example, you can add to intrusion detection is a technology that is available today, but you can have AI-based intrusion detection to make a much more flexible and powerful filters. You can have state of charge, state of health algorithm for the battery that use AI to make it a better prediction. So I can tell you, we have a lot and lot of customers and partners that are experimenting and trying to come up with new use cases, because it's really enabling OEM to expand the capability of the existing, let's say, standard functions with a new innovation, new capability. I give you another example that is pretty interesting. Is I recently bumped into an interesting case of the window wipe. Window wipe is a boring function, right? It just runs back and forth from when it rains, right? But you can also customize and learn. The AI can learn how do you as a driver like the window wipe to be actionated. So when it starts raining, for example, I like to have a lot of rain in my windshield, so I don't care. I can see through the water, so it doesn't bother me. But my wife, she goes crazy. One drop of water and everything goes off, right? So having the car that learns how you behave, how you like the car to behave, this gives you a level of customization that is unprecedented. And if there is one thing the OEM like, is to create a sense of affection, of attachment to the driver, such that they always stick to the same brand, right? And this is a way to get closer to the customer, to be more customized towards what the customer needs. So a great technology really coming up.
So what does that mean, given what you've just said, how are platforms like your S32N going to enable new business models for automakers? Are we moving towards truly upgradable, continuously evolving vehicles?
Yeah, absolutely. So the business model and the capabilities are immense. So one is giving new functionalities. And so this could be new capabilities like the logical functions or more and more AI models that come down to the vehicles. And these models can even be new virtual sensors that make your vehicle smarter, but at the same time not more expensive. Then you can also add agentic models, and that means you can talk to the car and say, "Hey, it's too hot in here," and the car will understand that it should close the window, start air conditioning, know that you like 20 degrees and not 25, right? And start the air conditioning immediately, right? So all this technology, it's really built around customizing the life around the user. And it's possible because you have a safe, secure platform that runs the vehicle functions, the window lift, the air conditioning, the motions, right? But also is capable of understanding the language of AI, so LLMs and MCP protocol and all this stuff, right? And then all these capabilities unlock also new services for OEMs. So one is they can sell more functions, but really what I see is the OEMs want to learn what really works and what doesn't, such that they can better optimize their product development, right? So making sure that they invest in the features that customers really care and drop the one that don't care. That's the primary way that OEM can monetize the data and the functions available in the car from going forward.
I'd like to point out that it's not just you that thinks this technology is cool. I mean, your platform has also been recognized with our Electronics Excellence Award at Embedded World earlier in the year. So what does that recognition mean for you and your customers?
So first of all, thank you. We are really honored for the recognition. It was great. And my boss was there. He was on stage. So thank you, Davo. No, it's really important for us because it's really a lot of work, and having a third-party validation and recognition is super important. And it's super important for our customers to see that there are products out there that are really worth considering. And finally, we spend a lot of energy in the automotive space, but I can tell you we see a lot of demand for this S32N product from outside, from drone manufacturer, from airplane manufacturer, from data center manufacturer. So a magazine like yours that covers such a wide market, it's really helping us to reach out the customers that are there and the potential customers that are there and that we don't pay enough attention to. But we will very much pay attention to these new guys now. Yes.
So if we were to revisit this conversation then in, say, 5 years, what will today's S32N architecture have unlocked that isn't possible in today's vehicles?
The new capabilities will be fantastic. You will have cheaper cars because a lot of these boxes are now functions that live in one place. You will have cars that learn and evolve around you. They get smarter because the OEMs can download and upload to your car new sensor, new intelligence, new capabilities that were thinkable before. And so S32N7 is really the key for that. And I'm really excited to see what will come, because I can see the interest and the pull from the market, and it's really amazing. It's really amazing. So I really look forward for the cars with S32N7. 2028. You don't have to wait for long.
Fantastic. Yeah, no, I'm very excited as well. And I have to say, I was there on judging day for the awards, and I've never seen the judges unanimously agree that a product should deserve to win. So congratulations again on that.
Thank you.
Is there anything else that you would like to add before we wrap up today?
No, I think that was a great conversation. As I said, we will support automotive, of course, but we will go also in all these other markets. As an NXP, we have a wider organization that can take care of that. And we work also with several distributors to make it happen. So I'm very sure that this will be a great success. And so hopefully we can have a conversation in a couple of years from now, and I can tell you how beautiful the world is from the NXP side.
Sounds like a date. I'll pencil it in. Well, thank you very much, and watch this space. It was a pleasure talking with you, Nicola, and enjoy the rest of
My
your day.
pleasure. Thank you. Bye-bye.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.